Hi everyone. Today we are going to be doing a one-way analysis of variance, and we are going to be using the same data set that we did in one of my last videos, which was on the independent samples t-test. So the particular data set that we'll look at for today's example has to do with cotinine levels in three different groups: tobacco users, those that were exposed to environmental tobacco smoke, and then the non-environmental tobacco smoke. If you happen to watch that independent samples t-test video, you know we only used groups 2 and 3. So this time we're going to use all three groups, more than two groups, one dependent variable, which is the mean cotinine level. So this is a nice problem for us to use the one-way analysis of variance feature. So we're going to start by just posing our hypothesis. The null hypothesis is that the mean cotinine level among all three of these groups is the same, and the alternative hypothesis would be that the means are not the same. Remember, that doesn't necessarily mean that all three are different from one another, but there's at least one that is different from the others. So we'll take a look. We're going to also just the premise for this particular problem is we're going to use an alpha level of significance level of 0.05 or 5% or a 95% significance level. All right, so let's go ahead and open up our SPSS. Here's our data set, and I will just double click on the cotinine. That should pop up our SPSS folder. Okay, so here's our data set. This is the cotinine levels. You see group 1, group 2, and group 3. If I go over to the variable group view, you can actually double click on this and see the 1 is smoker, 2 corresponds to ETS, and 3 corresponds to no ETS. We're not going to change those at this time. So I'll go back to data view. We can kind of scan through our data. You also see we have 120 data items, and it'll show this to us in SPSS, but I think this sorts out into 40, 40, and 40 quite nicely. 40 people in group 1, 40 people in group 2, and 40 people in group 3. All right, so let's go ahead and run our analysis of variance. So we will go to Analyze, Compare Means, and then down to the one-way Anova, one-way analysis of variance. Now, in a later video, I'm actually going to show you how you can go in and do a univariate general linear model and pretty much come up with the same result. But for now, one-way analysis of variance. All right, so here's our two variables. Our first one is a scale variable, measured cotinine levels. That is going to be our dependent variable. That's the one that's in common to all three groups. We're comparing that mean amongst these three different kind of categories. So that becomes our dependent variable. We'll put it in there. And the grouping comes down here to the factor. Now, last week we had to actually select and set these factor groups. This week we're using all three of the defined groups, so I don't actually have to define this or break it down any further. I do, however, want to turn on a couple of options over here. So the first thing I want to do is go to my options, and I'm going to want to take a look at the descriptive statistics. This will show me the means, the standard deviations, etc. for each of my groups of data. So I'll hit continue to go ahead and close that for my options. The other thing I'm going to do is do a post-hoc analysis. We're going to turn off both the Sheffey and the Tukey analysis, and we'll get a comparison at the end of not only whether we can reject the null hypothesis or not, but now we can do comparisons between the different kinds of groups. So we'll take a look at that right at the end here. Notice this is also set at a significance level of 0.05. Okay, well, I think that's pretty much it for setting everything up in SPSS. So now we can click OK, and it'll run our analysis of variance quite quickly. It's one of the things I really like about SPSS. And here's our output. So let's kind of scroll through this and see what we got. All right, so up top you have 40 smokers, 40 people that were exposed to environmental tobacco smoke, 40 people that were not exposed to environmental tobacco smoke. Here are the means, and boy, they sure look very, very different to me, but that's not good enough to just kind of eyeball them and say they look different. We actually want to test whether they are significantly different from one another. Here's the standard deviations, the standard errors, and so forth, the minimum and maximum. Now here's the output from our analysis of variance. The sum of the squares with the between groups and the within groups. We talked about this in seminar this week. Here's our degrees of freedom. Remember, the degrees of freedom between the groups is the total number of groups, which was 3, smokers, environmental tobacco smoke, no environmental tobacco smoke, minus 1. This was the total degrees of freedom. Degrees of freedom for each category is the number of people in that category minus 1. So 40 minus 1 is 39, plus 39, plus 39 gets us to the 117. You could also take the total here, 120, and subtract the number of groups, which is 3. So 120 minus 3 would be another way to reach that 117 degrees of freedom. But best of all, SPSS just gives us those numbers so we don't have to compute them by hand. Here's the total mean square, and remember the F value is the ratio of the between groups mean square to the within groups mean square, and this is where we come up with an F value of 20.856. And finally, we look over here and see a sig value of 0.000. Alright, so I'm going to just jump back and say since sig, which is the p-value, equals 0.000, we'll go ahead and put this parentheses sig value is 0.000, and this is less than our cutoff value, 0.05, we can reject the null hypothesis. All right, but let's jump back over to our SPSS data for just a minute. And let's talk about this F value, 20.856. So we can also look up this F value against the cutoff value that corresponds to our degrees of freedom and the specified alpha level of 0.05. We could do this in a couple of ways. We could look at the chart at the back of the book and look for a 2 in the numerator, which you're going to be able to find just fine, and then look for 117 in the denominator. Now you have to flip quite a few pages and you still won't find 117. It goes up to about 100, and then after that you have to just kind of interpolate a little bit, which is just estimate based upon the gaps that you had before. So instead of using the table lookup value, because we have a very large denominator degrees of freedom, instead I'm going to use an online calculator. So here's one. I just actually did a Google search for this one, and I found this particular one. It's got a lot of ads on there. Don't mean to do that, but it's danielsoper.com, or again, you could just Google an Anova F-test critical value calculator, and you'll find this. So the degrees of freedom 1, that's the numerator. So remember from our example, we had 2 because there were 3 groups. And a degrees of freedom for the denominator, we had 117, so I'm going to plug that in. And I'll leave in the probability value of 0.05 and press calculate. So here's my critical F value, 3.0737. Let's just take it as 3.07 right now. So our cutoff F value is 3.707. 3.074, I'm sorry, 3.074. And let's go back to our SPSS window. Our F value is 20.856. which is greater than the cutoff value of 3.074. So again, we can reject the null hypothesis. So we found that there is a significant difference between the means of the cotinine levels in each one in these three groups. So far, that's all we know, is that there's a difference. We don't know how big of a difference or where that difference lies or anything else. Okay, so finally let's go back and look now at our post-hoc tests. So this is where it's doing multiple comparisons. We're going to look at, we do have a fairly large number of data entry points, and we can afford, I think in this particular case, to be fairly conservative. So using the Tukey post-hoc comparisons, you can look at these sig values right over here. And you can see that except in the case of the ETS and the no ETS, we do have still a low enough level of significance to show that there is a significant difference in the means between the smokers and those that were exposed to environmental tobacco smoke, and in every pairing except in the case where you get the sig value of 0.183, which is between the environmental tobacco smoke and the non-environmental tobacco smoke. Now I know that in your book they don't necessarily talk about the Tukey one. You could look down here at the Sheffey model. But again, you see a significance level between the smokers and the environmental tobacco smoke and the smokers and the no environmental tobacco smoke. But you don't see a strong enough significance level between the environmental tobacco smoke and the no environmental tobacco smoke using this F test value. So I hope this has been useful to you. We have rejected the null hypothesis, and we can now spend our time interpreting the results and responding to our discussion board prompts and all of that other sort of thing. So I hope this has been useful to you. We've gone over how to use SPSS to run a simple one-way analysis of variance for a three-level or three-group population, comparing the mean level of cotinine in this population. Thanks, and have a great week.